I need to find the derivative of this function. And it's nicely written with y all by itself on one side, so I don't need to use implicit differentiation. But as you might remember, I really don't like using radical signs when I'm doing derivatives. So I'm going to rewrite it as a fractional exponent. So it is x squared plus 1 to the 1/2 power. And I have a quotient, so I'm going to use the quotient power, the quotient property, uv minus uv over v squared, prime. So y prime is equal to, well, u prime, that's my x, so that's just equal to 1, times v, which is x squared plus 1 to the 1/2, minus u, which is x, times v prime, which is 1/2 x squared plus 1 to the negative 1/2, that's using the power rule on the outside, times, I got to take the derivative of the inside, which is 2x. And I'm going to divide all that by x squared plus 1 to the 1/2 power squared. And yes, I know that something to the 1/2 power, and when I square it, it's just going to be x squared plus 1. But I really like to write it out, at least the first pass here, pretty fully, and then I'll simplify it. Because that way I can kind of go back and see if I missed anything, which you don't know, but when I did this problem just a couple seconds ago, I did miss something, and I was able to find it that way. So I have y prime is equal to, well, I'm going to start off here with 1 times anything is itself, so it's going to be x squared plus 1 to the 1/2 power, minus, now I think I'm going to pull my, well, I have the 1/2 here, and that's going to be multiplied by that 2, so that's going to go away. And then I have x times x, so that's going to be x squared, and then this is going to be x squared plus 1 to the negative 1/2. And that's all divided now by x squared plus 1. Now, I can't leave my answer like that. I know there's got to be a way to simplify it. I have too many x squared plus 1s in parentheses. And learning how to simplify something like this is just going to take time and experience. Sometimes you'll be going around and around and around, and it'll take you, 5 or 10 steps. In fact, I did one here that took me 8 steps, and then I figured out a different way that is only going to take me 4 or 5 steps. So here's what I'm going to do. I am going to multiply the top and the bottom here by x squared plus 1 to the 1/2 power over x squared plus 1 to the 1/2 power. So I'm multiplying it by 1. And the reason I'm doing that is because I was looking at it and I thought I could see, well, if I multiply this by x squared plus 1 to the 1/2, my 1/2s are going to add together and just become a 1. And when I multiply this piece by x squared plus 1 to the 1/2, well, again, I'm adding the exponents, same base. It's going to be a 0, so it's going to go away. So it's going to look like this. It's going to be y prime is equal to, now I'm going to do that first multiplication right here, distributing that, and that's going to become, well, it's just going to become x squared plus 1. And then I'm subtracting x squared. Well, now this times that, as I said, it's going to be x squared plus 1 to the 0, because negative 1/2 plus 1/2 is 0. So that's just times 1. And then in my denominator, I'm going to have x squared plus 1 to the 3/2. Again, same base, this is to the first power, same base, that's to the 1/2 power. 1 plus 1/2 is 3/2. Well, my numerator, hey, that looks pretty exciting. y prime equals x squared plus 1 minus x squared, whoa, divided by x squared plus 1 to the 3/2. Well, if I have x squared minus x squared, I'm just going to be left with 1 divided by x squared plus 1 to the 3/2. Now, just coming back here, how would you know to do this? Again, it's really just a matter of experience in algebra. You should, if you look at something like this, and you see all these x squareds plus 1s, and they're the different exponents, you should know that you need to simplify it in one way or another. And, you know, there's any different number of different ways that you can do it, but find one and work it out till the end, and I guarantee you will get this answer. I would practice that.